Wanted to give you some homework help on this lesson 2.5. Just selected a few of the problems. I hope by seeing these it will help you do the rest of the problems. So let's take a look at this problem number 4. It's on page 121. And the goal here is to be able to take a graph of a piecewise defined function and come up with the actual equations that represent each of the pieces. And so since our y-axis is defined for us as g of x, then that means our function for the pieces will be g of x equals, and now we're going to represent each of these lines using their equation. Okay, so I'll just kind of number these as we go. Let's start with this line, this horizontal line that passes through the y-axis at 6, but it doesn't go forever and ever in both directions. It starts at -5 for the x coordinates, the domain, and then it continues on forever and ever left. Okay, so we start off with the equation for this horizontal line, which would be g of x, or f, or y, sorry, if our y-axis was not labeled, it would just be y equals. But we'll go with g of x since that's what they've labeled the y-axis. So g of x equals 6, but according to this line, that's only true if the x values, the x coordinates on this line, are less than or equal to -5. So you got to remember these units are in twos. This would be -5 on the x-axis. So we're only using x coordinates on this line that are -5 and smaller. And that's what this inequality states. Okay, that takes care of that piece. Now let's go up to this piece. This is just a line segment, but let's come up with the equation for the entire line, and then we'll show how it's really been chopped off by limiting what the domain can be. So it's a y equals mx plus b. We can tell the slope just by counting rise over run. So I'm going up 2, left 2. Okay, remember these are in twos. Up 2, left 2. So that's really another way of saying -1. Let's do some little scratch work down here. So we have a slope of -1. We can't really see the y-intercept. Some people have suggested, can't we just extend the line? And you can try that. It doesn't always work. Sometimes we do end up with a fraction value. So I'm just going to work through this as though we really can't tell for sure what the y-intercept is, but we're used to doing that. It's a little bit extra work, but that's always good for us to practice a little bit. So let's use the point -2, 6. That's on this line right there. And along with the slope of -1, we can find the y-intercept pretty easily. Y equals mx, and solve for b. 6 is 2 plus b, and sure enough, we got a b of 4, +4. So subtracting 2 from both sides. So the equation for this line, the entire line, would be g of x equals -1x, or just -x, plus 4. But the line has been chopped off so that only certain values for x are included. So we're going to include only, in the domain, only numbers that are between -5 and -2. And here's how we show between: -5, -2. Only values of x that fall between those two numbers. And notice we don't put lines underneath those because they're open circles. -5 and -2 are not part of the domain, but any number in between them would be. All right, so 2 down, 1 to go. And now let's take a look at this other line. We'll call it number 3. Once again, we need a slope. Okay, we need y-intercept. Well, hopefully you can see there is a y-intercept there, and we're gonna pretend that, or assume they're not going to trick us here, that actually is positive 1. So my b is 1. Can we tell what the slope is? So that's up 1, right 2. Or you could go up 2, right 4, but in either case, 2 over 4 is 1/2, just like 1 over 2. So we got a slope of positive 1/2. Well, that makes it nice. If you know what the slope is and you know what the y-intercept is, then it's easy enough to write the equation g of x equals 1/2 x plus 1. But in this case, it's only for certain values of x. Again, we're going to restrict the domain. And it looks like it's only for those values for x that are -2 and bigger. Or using inequalities, we would say x is greater than or equal to -2. Okay? And so that takes care of problem number 4. So let's move on. Next problem is number 15 on the next page. And this time we are given the function, how each piece is defined, and we've got to come up with the actual graph of the 3 pieces. Okay, so it's really going in the opposite direction of the previous problem. And we can't forget that once we're finished graphing, we need to identify the domain and the range if we put all of the graph pieces together. Okay, so here we are with this line g of x equals -2. That's just another way of saying y equals -2. I guess I'll go ahead, instead of saying y here, this should be g of x, since that's the way our function is labeled. So that's not a point, I just marked out the y. So the line y equals -2, of course, would be horizontal, crossing the y-axis at -2. And this case, however, we're only including x-coordinates that are less than -4. So instead of drawing a line that goes forever and ever in both directions, I'm drawing a line that has an end point at -4 for x, and then it's going to continue on forever for numbers that are less than -4. Okay, so let me get my line draw tool, and we just need an arrow on one end, and so we're going to show this line going forever negative. Okay, so that takes care of this first part of the function. This is g of x is -2 only for these domain values. Alright, so now let's take care of this next line. Notice this is a line. It has a y-intercept of -3. It has a slope of +1, up 1, right 1. And if there were no domain restriction, then that would be the line. We would just connect those dots and arrow both ends, but we can't do that here because this is only true for domain values that are between -1 and +5. So let me just keep on going with my dots in the same pattern. So it's as though -1 for x, which would be here, is the left end. I'll go ahead and make a solid dot there because we are including -1 because it says or equal to. And then on the right end, we have to stop where x is +5. Okay, which is 1, 2, 3, 4, 5 right there. This is where x is 5. This is where x is 5 on my particular line. That indicates the right end point. And so now we just take our ruler, and this is just going to be a segment, and we're going to draw a segment that includes just those points, showing a restricted domain, limited the values for the x-coordinates on that line. All right, 2 down, 1 to go. And now let's look at this third line. And they're a little mean to us here, I guess. They give us a y intercept of negative 15, y equals mx plus b. Remember, I don't have 15 or negative 15 places from which to start, but there's more than one way. We know to do a table. Just think of function cornhole. You took a beanbag that had inputs, and then you plugged it into a particular function to get an output. Those represent ordered pairs on the line. So let's just pick, this is the independent variable. We can pick anything we want. Let's try to pick some numbers that we think will be easy to plot so that we don't have to make up, we don't have to change our units. For example, I'm just going to pick 4 because I know right off that if x is 4, 2 times 4 is 8, and 8 minus 15 is negative 7, and those fit pretty well, pretty easily on my graph section here. So just plot the point for negative 7. Right 4, down 7. That point is on the line. Okay, and we know from there that we have a slope of 2. So if you don't want to plug in another point, then you could just continue with your up to right 1, up to right 1 idea. Okay, now I'm going to go ahead and draw this, and then we're going to cut it off. Okay, now I'm going to go ahead and choose just an arrow on one end because hopefully you can see that we're not going in both directions. We're only going to include x values that are greater than 7. So once again, just to illustrate for some people who may be struggling just a little bit, I'm going to start with that line, but now I'm going to show how this line needs to be chopped off to include only x coordinates that are greater than 7. This would not be correct if I stopped here, because right now I'm including an x coordinate of 4 and 5 and 6, but I can't include those. I can't even include 7. I can include every number bigger than 7, but I can't include 7 itself. So let's go ahead and shorten this line. Okay. Some people actually just use their eraser. They go ahead and draw and then use their eraser. 1, 2, 3, 4, 5, 6, 7. Okay, and it's still not exactly complete because I have a solid circle indicating that 7 would be part of the domain. So I'm going to do one little tweak here and put an open circle at 7. Now it's good because I can involve any x coordinate as long as it's bigger than 7, and that represents this particular, I guess we'd call it an array. It only goes in one direction. Okay, so now let's put it all together and see if we can come up with a domain. Domain means, in essence, what you're doing here is you're trying to pick out what numbers from the x-axis are used. They are part of this overall graph picture. If you put all these graph sections together, what numbers are being used as x coordinates? Well, it is obviously disjointed. There is no connection. We've got some numbers, as you can see right in here, that are not being used at all in this little space. And that happens also over here. We've got some numbers that are not being used in this space. So how are we going to state the domain? Well, we want to know the numbers that are being used. So really it amounts to this. We're basically just going to repeat what has been given to us in the function, since we can't just say all real numbers, because obviously that's not true. So for stating the domain, we're going to say all x such that, first of all, x has to be less than negative 4 because of this graph. Put a little semicolon, and now we'll include the part that involves the middle graph. So x has to be between -1 and 5. And then finally, x has to be greater than 7. So this was a little unique because it's disjointed, and we need to not include in the domain these numbers that are in these gaps. So really we ended up just repeating the restricted domain that was given to us in the original function. Okay, well, the range. Range, then you're looking this way, and what y coordinates are being used if you take all of these pieces and you think of them as a whole, as one picture. Well, I noticed that from 1 and all the way up to positive infinity, we're using every single y because of this graph. Well, if you take this graph and you put it together with this one, okay, it's almost like, all right, now we're using these, but we're going to include a few more. Okay, so if you put these two lines together, you're already using from -1 up to positive infinity, and it's almost like we're just going to take that group and then we're going to include with it these because of this bottom part. So now we've extended the range to include all numbers bigger than, including -4. Okay, just put those two together. You already had bigger than -1, and now we're just going to throw in these because of this bottom segment. And that's going to include, obviously, this is where y or g of x is -2. Well, that's already included as part of this little segment that we've already included as part of our range. So the bottom line is every number, I'll just draw a line, every number for y that is from -4 and then extending upward is going to be involved in as ordered pairs if we take all of these pieces and put them together. And so the way we say that with inequalities is we say g of x or y such that any number that is greater than or equal to -4 will be used if you put all of these pieces together. We're going to be utilizing as y coordinates any number that is -4 and bigger. Okay, and so that takes care of our problem number 15. Okay, so here we are at number 17. We're back to taking a graph and seeing if we can come up with the equations that represent the pieces. So our piecewise defined function will be g of x, because that's the way the y-axis is labeled. And now we're going to have three equations. Okay, and we'll just start over here with number 1, this one that's pointed toward -infinity, has an end point here with this open circle. Obviously that's a line, so we're thinking y equals mx plus b. Let's see if we can identify the slope. So if we start here at -4, 0, we go up 2 and left 2. That's obviously -2 or 2 over -2, which is -1. All right, so we have a slope of -1, or we'll just say -1x. And we don't know for sure what the y-intercept is. I mean, we could maybe try to extend the line, but I'm a little more cautious than that. So I want to try to figure it out using algebra. So I'm going to take a point on this line, the x-intercept, knowing that the slope is -1, and I'll just find out what b is. Y equals mx plus b. 0 is 4 plus b, so b is -4. Okay. All right, so that completes the equation for this line, but now I need to show how the domain is restricted. And again, you got to be careful because these units are in twos. So that is actually where x is -3. So we're not going to include -3 as part of the domain, but we are going to say that any number less than -3 will be a part, they'll be used as x coordinates. So only if the x values, the x coordinates, are less than -3. And that completes this number 1. All right, let's move to, we'll call this one number 2 here in the middle. Obviously it's a line segment, so it started off as the equation for a line. So let's see, maybe a little hard to read. This is our origin. I'll just put a little dot here to indicate the origin. So we have a y-intercept, looks like 1. Okay, let's come down here, and so for this line number 2, our b is 1. And now let's identify the slope. Remember, this is also 1. So for the slope, we start at the y-intercept, and we go up 1, right 1. Okay, so that's a slope of 1. So this one's going to be pretty easy. So we put that together, and we have, for this part 2, we have g of x equals x, 1x, plus 1. But we need to show that since the line doesn't go forever and ever in both directions, we have a domain restriction again. So here's -3, here's +1. They're both included because of solid circles. So we're going to show that the domain, or x values, are between, so here's how we indicate between, -3 on the left side and +1 on the right side. And I left out my if. Let me back that up a little bit. Okay. -3, +1, all x in between those, including those. All right, so let's take these off. And then we got this easy line down here. These horizontal lines are just, it would be y equals -6, or in this case, g of x is -6. But it's only for certain values of x, as you can see. Any number for x greater than +4. We're not going to include +4. Okay, and that is your answer for number 17. And now for this last problem, I don't want to do all of it for you because I want you to make sure that you understand, and hopefully based on the 2 problems like this that we've already done, you'll start to pick up on how these work. I do want to give you a little help though, because for some people this last segment might be a little difficult in determining, well, what are the points I use, what's the slope. Let me just give you some help here just on this last part, and I'll call this this third section over here. So let me just give you some definite points. First of all, this x-intercept is the point 7.50. Okay, and it's really hard to tell, where it's going to, and in between you kind of have to guesstimate. So I'm going to take some guesswork out and really help you out. So if you're watching, this should get you to the answer. Another point on this line is the point 10.5. Okay, so if you know 2 points, then you know how to find the slope. And this is just a review of what we've already been doing. Find the slope, and then you can use the slope and one of these points in order to find the b. Okay, so I don't want to do all of this with you, but I wanted to at least give you some guidance. If you just take I'm going to give you 2 points for this third section, and that should, if you know 2 points, then you can take it from there. and get the rest of the answer. So I hope this helps, and if you still have questions, I'm available. You can send me an email, come to academic support. Work hard on this. Make sure you have good understanding. These obviously will be on your test, and let me know if I can help you.